Shown on this page are 6 trig functions: sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotan theta. For our purposes, we're only interested in these 3. These 3 right here are only shown here for completeness. We're going to be interested in these 3 for our video. On the right-hand side is a right-angled triangle. We know it's a right-angled triangle because of this symbol here in the bottom corner. And that makes this a 90-degree angle, or also known as a right triangle. The angle theta is the same as all the thetas that you see in these equations. They all represent that particular angle. However, theta does not have to be down here at the bottom left. It can also be this angle on the top right. For instance, if I redraw this triangle, and I'm going to place theta on the top. This is still a right angle triangle, so it's 90 degrees down this side. This length right here will be the hypotenuse. Hypotenuse is always opposite to 90 degrees. And this length right now becomes, because it is joining to the angle theta, this becomes the adjacent length. From here to here is the adjacent length. And this one here now becomes the opposite length. From here to here, the actual length. You'll notice then that the opposite and adjacents will flip. It all depends on where the angle theta is being defined. Let's do some word problems regarding sine, cosine, and tan. Consider this right angle triangle. Degrees here. I'm going to put theta there. I'm going to give this length, the hypotenuse, a dimension, 15 centimeters. And we want to find this length. And that length happens to be opposite the angle theta. So it's actually going to be the opposite. I could also superimpose this triangle on a Cartesian plane. Standard XY coordinate system, such as this. You don't have to do this, but it's understood that this can be superimposed into a simple Cartesian plane, XY plane. To find x, find the length x. First thing we need to do is write down what is given. Sometimes with stuff that is given in an actual word problem. In our case, it happens to be a little picture. So we're going to write down or transfer this information in terms of what's written in the equation itself. So what's given? Theta is equal to, oh, I forgot to give it an angle here, 35 degrees. So theta is 35 degrees. The hypotenuse is given to us as 15 centimeters. And obviously the angle we want to look for is the opposite, is equal to x is equal to the unknown. Now that we have these 3, we can then choose an equation in order to solve for x. We need to find an equation that has all 3 of these variables within it. If you look at tan theta, we have theta, and we have an opposite. We need opposite and we need an adjacent. We only have an opposite and hypotenuse, so tan theta is not the equation we're going to use. Cosine theta requires adjacent and a hypotenuse. We have an opposite and a hypotenuse, so cosine theta will not be suitable to solve this problem. And what's left over is sine theta, and we'll see if it has all 3 variables. We need theta, opposite, and the hypotenuse, and we have theta, opposite, and the hypotenuse. So we're going to use sine theta to solve for x. Is equal to opposite divided by the hypotenuse. We have all the information we need right here, just a matter of taking this information out and putting it into the equation. And the angle theta is 35 degrees. is equal to the opposite, which is what we don't know. So we're going to simply call that x, divided by the hypotenuse is given to us as 15 centimeters. Up to this point, the trigonometry is done. All that's left now to do is some algebra. In order to solve for x. Looking at this, 15 centimeters is in the denominator, and we want to move the 15 centimeters to the left-hand side in order to isolate the x. We do that by multiplying both sides. Since we're dividing by 15, I'm just going to extend this line. This is a division line. If it's divided by 15 centimeters, if I multiply this by 15 centimeters, the right-hand side, whatever I do to the right-hand side, I have to do it to the left-hand side. And those two then will cancel out. This equation then would look like this, just cleaning it up a little bit. Is equal to x. We've isolated the variable that we need. Now just a matter of using our calculator and solving this. We take the calculator and let's solve for a sine of 35 degrees. Now the unit for sine is degrees right now. Once we do the actual calculation of 35 degrees, put this in here of sine 35, this number now becomes a dimensionless number. The sine of 35 degrees, I'm going to just simply write it down here, 57357. This is now a dimensionless number. The degrees cancels out once you do the sine of that particular number. And we're going to multiply that by 15 centimeters, and that's equal to x. Completing the multiplication on the left-hand side, we already have the value for sine 35. I'll just simply multiply this by 15 times 15. And there's my final answer for x. I'll just simply write it down here. 8.6036464 is equal to x. It has units because the units that are left over from the above equation is the centimeters. This one here is the dimensionless number, and we have centimeters is equal to x. Now before we finish this, we need to reduce this to proper significant figures. Proper significant figures. And how do we know what's the significant figures to reduce this to? Well, we look back at the original question, and the original question gives us values in two significant figures. 1, 2 for the argument of the angle, and two significant figures for the length of the hypotenuse. Therefore, the final answer cannot be greater than two significant figures. So we need to reduce this or round it to two significant figures. Two sig figs, and the units is going to be centimeters because that one's dimensionless, is equal to x. Let's do it another word problem. Consider this right angle triangle, similar to the one I just did earlier, at 90 degrees. That length is 15 centimeters. We're going to keep that angle at 35 degrees. And let's solve for x yet again. Again, this is on a Cartesian plane. You can superimpose this on a Cartesian plane as such, xy plane. And sometimes there's arrows drawn in there, it goes on to infinity. But instead of solving x right here, I'm going to move the x from here over to this side. Just simply take that length of x and slide it over. Here is now the position of the x which I wish to solve. And the triangle now basically changes from this one to that one. And the angle here is 90 degrees. The angle I'm interested in down here now, I know this is 35. This whole thing right here has to be 90 degrees. Therefore, 90 minus 35 will give me this angle. 90 minus 35 is equal to 55 degrees. I'm going to redraw this triangle now. I'm still solving for x. Here's my right angle. The distance I want to solve for is still x. The angle I now have in this triangle is 55 degrees. And the hypotenuse is still 15 centimeters. I haven't really changed the question much. All I've done is rearranged where x is going to be. Excuse me. Again, as before, write down what's given in this triangle. We know that theta given to us now is 55 degrees. We also know the hypotenuse is 15 centimeters, and we want to find x. And x happens to be, if this is the angle, this one here would be the opposite, and x now becomes the adjacent. X is the adjacent, and it is the unknown that we want to find. Same as before, we now have three variables. Looking back at our three equations, I'm trying to put all these on the screen. Which one of these three equations has all of these unknowns in it? The tan theta requires opposite and adjacent. We don't have an opposite. We have hypotenuse and adjacent. Cosine has hypotenuse and adjacent. That's perfect. And the sine requires opposite and hypotenuse, which we don't have. So the one that works is the cosine. Cosine theta is equal to the adjacent divided by the hypotenuse. Putting in the values, cosine, now the angle that we have here is 55 degrees. It's equal to the adjacent, which is what we were looking for, x, divided by the hypotenuse, which is 15 centimeters. Again, the algebra at this point, the trigonometry at this point is complete. All that's left now is to do a little bit of algebra. Okay. Find x. X is already in the numerator, so we're going to leave it there. We don't no reason to move it. Just leave it on the right-hand side. And we need to move the 15 centimeters from the denominator over to the left-hand side. We'll do the same as before. We're going to extend the division line. Multiply this by 15 centimeters on the right-hand side. Whatever you do to the right, you have to do to the left. And the 15 centimeters cancel out. Just to clean this up a little bit, 15 centimeters times cosine of 55 degrees is equal to x. Again, with the calculator, you want to find the cosine of 55 degrees. .573. And it becomes a dimensionless number once you take the cosine of an angle, dimensionless, and multiply it by 15 centimeters is equal to x. Completing the multiplication, we already have this in our calculator. Just multiply it by 15 is equal to 8.6. And the units is centimeters is equal to value of x. And as before, we have to reduce this to proper significant figures. Going back to the original problem, the significant figures given to us was 2 sig figs here, 2 sig figs, which we calculated earlier. So this needs to go reduced to 8.6, 2 significant figures, 1, 2. The units will be centimeters is equal to the distance x. And it's the same x as we found earlier. And one more. Now consider this triangle, similar as before. You have right angle here. This time we want to find this length. We'll call it y. And the angle is still 35 degrees. And we're going to make that length, which was the original x, which we solved for earlier. that length of x as 8.6. Write down what's given in terms of the values in the equation, or the variables that are in the equation. Theta is equal to 35 degrees. If this is theta, this one here, opposite, must be the opposite, is equal to 8.6 centimeters. And we want to find the adjacent. Is equal to y, and that is the unknown. So we have the three variables. Well, when you make this list, by the way, you have to also include the unknown. So everything is included here, and then we just find the equation that best solves, that best suits all of these three variables. Looking at sine theta, we had opposite and hypotenuse. We have an opposite and adjacent, so sine theta is no good to us. Cosine theta requires adjacent and hypotenuse. We have an opposite and hypotenuse, so cosine doesn't work. And tan is opposite and adjacent, which matches all three what we need. Therefore, we're going to use the tan function. Opposite divided by the adjacent. Putting in the values now into the equation. Tan of 35 degrees is equal to the opposite, which is given to us as 8.6 centimeters, divided by the adjacent is what we are looking for, and we'll just simply use the variable y. Again, the trigonometry up to this point is complete, and we just have to go on into a little bit of algebra to solve for y. In this particular case, we need to isolate y. Y is in the denominator. That is a bad place for it to be. We need to move our variables into the numerator. To do that, we're going to multiply both sides by y. Whatever we do to the right-hand side, you have to do to the left-hand side. And the y's cancel out. That effectively moves the y to the left-hand side, and more importantly, it puts it in the denominator, the numerator, excuse me. Cleaning this up, y times tan of 35 degrees is equal to 8.6 centimeters. Going further, in order to isolate y, we have to divide both sides by tan of 35 in order to move it to the right-hand side. So if we take all of this and divide tan of 35 degrees, whatever we do to the left-hand side, we have to do to the right-hand side. And the two tans cancel out. Understand, the only reason I'm able to do this is because this is a multiplication sign. Should this have been a plus sign, I would have to take extra steps in order to move this to the right-hand side. But because it's a multiplication sign, everything here is multiplied and divided, we can go ahead and take this a little sort of a shortcut. Cleaning this up a little bit, y is equal to 8.6 centimeters divided by the tan of 35 degrees. Finding what tan of 35 degrees is in the calculator. And this becomes 8.6 centimeters divided by 0.700207538 from the calculator. And it becomes a dimensionless number, as I mentioned earlier. The only units left then is the centimeters. And for y is equal to, we can take 8.6 and divide it by this value. Doing that again. 8.6 divided by the tan of 35. And the number is 12.28. 207,286. The units, the only unit left over is the centimeter. And that makes sense because we started in centimeters, we should finish in centimeters. Putting this to proper significant figures. Same as before, we go back to your original question. The question was given to us in two significant figures for that length, two significant figures for the actual angle. Therefore, this cannot be greater than 2 sig figs. We reduce this to 12 centimeters.